And there, this is it. So this is the recording of our lab 7. Look at our exercise 1. Our exercise 1 is that we need to introduce what is EL in Python. So if you look at these tests, you will see it will return just like the legs, and it will return like the parts. So this is one part, and this is second, and third, and fourth. So, and here you can see we are repeat. So here, this is our answer. And what is L in Python? The L keyword in Python is used to create the generator function. A generator function is a special kind of function that returns a generator iterator, which can be used to iterate over a sequence of values, unlike a regular function that returns a single value using the return statement. A generator function can yield multiple values, one at a time, pausing a state between each one. And here is our exercise 2. And exercise 2 do not have any descriptions, but if you look at this test, you will see this 2. It comes from this 1 plus. And this 3 is come from this 1 and 2. This 3 is also 2 and 1. So let's go on. This 4 is, yes, 1, 3, 6, 3, 3, 4, 3, 1. So this is our next description. So here you can see at first we can initialize our answer because you will see if here is nothing, it always have the 1 and all is the same while true. And we yield it like the breakpoint. And here just like this comprehension 2 plus the li and li plus 1. And okay, here is exercise 3. You will read these descriptions. So what is this problem description tell us to do? We will get a input is a list of integers L, such like the L1, L2, and L3. And we need to output. We need output N1. We need to put N1 lines of rank 1x, which means x without indentation. And between each pair of 1x, output N2 lines of rank 2x, which has identified with one tab. You see, one tab. And between each pair of 2x, we output N3 lines of rank 3x, which indented with two tabs. So here is our solution. My solution has a helper function. Like the generator. Print how many tabs. Use the slices. And here is the recursions entrance. So if the list is empty, we return directly, and we get the number of lines to output at the current level. And we use a loop to output n lines of the current levels x, which each line having the corresponding number of tab characters based on the rank. After each output, if it is not the last element of it is not the last line, recursively call helper to handle the next level of X lines. And the standard solution is similar. You will see Eggman also used the recursion like this. And in our XS4, we can read these descriptions. Okay. So if you are watch it radio on your YouTube, please stop, pause it, and read the descriptions. So that means uh this problem given a list L of integers, and we need to break it down into sublists of equal length, and which length is maximal. And the process is recursive. Each sublist is further break down in the same manner. The original list should be preserved. That means not modified. Okay, so let me introduce myself. So at first we got its length, and we try to find the maximal sublist length greater than one. So after we get that, we can split the list into sublist. But here, we need to find the maximum one. So here, we need to use the recursion. We aim to split the list into the largest possible sublist of equivalence greater than 1 that evenly divide the length of list. I'm checking the Eric Martin standard solution. Eric Martin standard solution, yeah, same with me, but he used the square length here. Here is better than me, I think. Okay, so our exercise 5. Pause it and read the descriptions. We are given a special list L, a list whose elements are integers or other special lists. We need to return a dictionary. Yeah, I think this is hard to read. I understand that. So I break it down. So if the key is I1, so the LI1 is an integer E. So that means here, if the key is I1, I2, the L1, the LI1, I2 is an integer E. So can you understand? So this is the problem set that the key and the value in the dictionary. Okay, so look at this. Here we only have one dimension list, and the one is index is zero. So here, zero as the key, one as the value. And look at this one. This one we have outside we have two dimension, and inside we have is this one two dimension. Here is one dimension. Here is our second dimension, our third dimension, and our fourth dimension. Okay, so you will see here, our one dimension we only get the three. So here is one three because here is the index zero. Here is the index one. So our value one has a zero zero because it's at the zero index sublist, and inside this sublist, the one is at the index zero. So we get the zero zero and go on here zero one zero zero where we where it come from. Here is a zero, and here is one because the value one is index zero. So here is index one. And inside two, and inside we get two. So here is zero one zero zero for for the four dimensions list. Yeah. So inside this exercise five, we need to handle any depths of nesting. Hmm, I find that my solution has some complex. Let me introduce the standard solution. Okay, here you are. We can use the is instance to check if an element is an integer or a list. Here is to check that if it is an integer. If it is, so you can put these values inside the dictionary. If not, so that means you need to recursive the next dimension inside the list. Easy, right? So inside the exercise six, mhm, you may don't understand what is the Fibonacci. Okay, so the Fib is means that the Fibonacci sequence. So the given problem is not strictly about the Fibonacci sequence, but it generalizes similar principles to a broader set of the recursive relationships. So in the problem, you are asked to compute the nth term of a series, where the series is defined by some initial terms. The initial terms is the n, the first terms, and a set of recurrent factors. Then the Fibonacci sequence is a special case of such a recurrence relation. where each term is the sum of the two preceding terms. I found that my solution was wrong. So here, let me just introduce the Eric Martin Stern solution. So here, we need to have another arguments and check the cause. So how many times this function called? So each time the number of courses will plus one, right? And then we can print something out like at this part, right? Computation NB1 of 510 like this. And then we calculate our Fibonacci number. Our Fibonacci number is so this is our Fibonacci number calculate. And so here we can print out like this, computed as how many. And here we just return our Fibonacci number. Yes, it is. Okay, so you will find that some of these exercises answer is not as same as my blocks. So if you have any questions, please send your questions to my email or ask on the ED platform and add me. Okay, so here is our lab 7. Thank you.